Hello students, this is K.R. Ulagu, Assistant Professor of Chemistry, J.J. College of Arts and Science, Autonomous, Pudukkottai. Today we are going to discuss about OSTWALD dilution law and their applications. First we see about state OSTWALD dilution law. According to Arrhenius' theory of dissociation, an electrolyte dissociates into water solutions. These ions are in a state of equilibrium with the undissociated molecules. This is called the ionic equilibrium. OSTWALD noted that the law of mass action can be applied to the ionic equilibrium as in the case of chemical equilibria. Consider a binary electrolyte AB which dissociates into A plus and B minus ions, and the equilibrium state is represented by equation AB gives A plus plus B minus. Let C moles per liter be the concentration of the electrolyte and alpha is degree of dissociation. The concentration terms as equilibrium may be written as experimental verification of OSTWALD's law. The OSTWALD's dilution law can be verified if the values of alpha, the degree of dissociation at a different dilution, are known. The values of A are determined experimentally by using the relation A is equal to lambda V divided by lambda infinitive, where lambda V and lambda infinitive are equivalent conductance at dilution V and infinite respectively. Their values are found by conductance measurements and Coulre's laws. The values of A at various dilution thus determined are inserted in expression. Kz is equal to alpha squared divided by 1 minus alpha V. If the values of K, C come out to be constant, the OSTWALD's law stands verified. Limitations of OSTWALD dilution law. Limitations of OSTWALD's dilution law. The law holds good only for weak electrolytes and fails completely in the case of strong electrolytes. The value of alpha is determined by conductivity measurements by applying the formula lambda V divided by lambda infinitive. The value of alpha determined at various dilutions of an electrolyte. When substituted, it gives a constant value of K only. In the case of weak electrolytes like acetic acid, ammonium hydroxide, etc. The cause of failure of Oswald's dilution law. Oswald's fails due to following reasons. The law is based on the fact that only a portion of the electrolyte is dissociated into ions at ordinary dilution and completely at infinite dilution. Strong electrolytes are almost completely ionized at all dilutions, and lambda V by lambda infinitive does not give accurate value of alpha. When concentration of the ions is very high, the presence of charges on the ions appreciably affects the equilibrium. Hence, law of mass action its simple form cannot be strictly applied in the case of strong electrolytes. Equilibrium definition: a state of the system in which both forward and backward processes are balanced is called equilibrium. Types of equilibrium: there are 4 types of equilibrium. One is physical equilibrium, second one is chemical equilibrium, third one is phase equilibrium, and fourth one is ionic equilibrium. Metallic conductors. Metals which conduct electricity due to the mobility of outer shell electrons of atoms present inside them are known as metallic conductors, and this process is known as metallic conductors, and this process is known as metallic conductance. There is no chemical reaction in the metallic conductance. Electrolytic conductance. Solutions of chemical compounds are in their fused state containing opposite charged ions conduct electricity by the mobility of ions are known as electrolytic conductors or electrolytes, and this process is known as electrolytic conductance. Then next we see about types of electrolytes. There are 2 types of electrolytes. One is strong electrolytes, second one is weak electrolytes. Strong electrolytes are compounds which are completely dissociated into positive and negative charged ions when dissolved in water. The next, weak electrolytes. Weak electrolytes are compounds which are partially dissociated into positive and negative charged ions when dissolved in water. Thank you.